The star Bug-Juju, not to be perplexed with the individual from the film, is without uncertainty a huge grand body. In the event that we were to exchange bug juice with the Sun, it would connect past the orbit of Mars and even come to the space rock belt. What's extensively more concerning is that the James Webb Telescope has made an upsetting new exposure about Betelgeuse. Neil deGrasse Tyson has a few words on the subject. Notwithstanding its closeness of 700 light-years to us, Bug-Juju is the closest star to our planetary framework that specialists expect will ultimately end its life in a cosmic explosion impact. Renowned astrophysicist Neil deGrasse Tyson has been vocal about insect juice, noting its dumbfounding size. What's more, its stunning red-orange color makes it one of the most unmistakable stars in the night sky. He says that it's the closest star to the Sun that will, with a high probability, end in a cosmic explosion. Like any star, bug juice will ultimately run out of fuel in its core. As it starts changing, it will grow so extraordinarily that it will overpower the orbits of Mercury and Venus and come incredibly near Earth. Imagine actually taking a look at the sky during twilight and seeing a piece of the sky illuminated by creepy-crawly juice. Bug-Juju is known for its variance, with its brightness differing over time. At its pinnacle, Betelgeuse can sparkle unimaginably brightly, almost matching the most splendid stars above. With a degree near nothing, there have been speculations flowing about bug juice experiencing a cosmic explosion, suggesting a potential frightening occasion for eyewitnesses on Earth. Anyway, this claim probably won't happen. It's essential to grasp that a star's brightness can change fundamentally. Contrasting bug squeeze and stars like Riel and Birch Honorable further complements this point. Riel and Birch Honorable, while sometimes appearing similarly splendid, can differ fundamentally in their brightness. There is sharp interest in standing the situation with this uncommon star. Regardless, conversations about a possible impact lead analysts to maintain that they are observing Betelgeuse's behavior to handle its changes, and to distinguish any significant alterations that could signal an approaching cosmic explosion event. The speculation about bug juice exploding has gotten attention because of the star's size and its significance in the night sky. Anyway, stargazers and astrophysicists advise us that foreseeing such divine occasions isn't clear. While Betelgeuse's new dimming has earned attention, it's fundamental to remember that stars, including Betelgeuse, go through normal cycles of variation. Specialists continue to notice and investigate creepy-crawly juice using different grandiose instruments, including the James Webb Space Telescope. This cutting-edge telescope has improved our capacity to concentrate on far-off stars and cosmic systems. Its perceptions of insect juice provide significant bits of insight that assist in figuring out the star's behavior and potential changes, adding more pieces to the riddle of this intriguing divine body. The course of a star coming to the end of its life and culminating in a cosmic explosion is a complex cosmic event. While Betelgeuse has stood out and raised questions about a potential cosmic explosion, scientists approach such possible results with caution. Learning more is an opportunity about the life cycle of stars, their behaviors, and the ultimate destiny of these massive divine substances. The evolving splendor of creepy-crawly juice results from various elements, including its size, temperature, and distance from Earth. This variety in radiance is an outcome of the star's ordinary cycles and qualities. Over a time of slightly more than 5 years, Betelgeuse has experienced significant variances, presenting captivating challenges and producing scientific interest in understanding these varieties. Aside from Bug-Juju, this striking star is referred to by alternate names like Belus, BGE, and Batel, highlighting the variety in naming across different cultures. It's fascinating how a single divine body can have unique names and spellings, each originating from historical and phonetic contexts. The origins of the name Scarab Juju can be traced back to the Arabic language. Scientists often debate the most fitting spelling and articulation for this name, with Bu considered more fitting in its scientific usage found in the Orion group of stars. Bug-Juice sparkles as a red supergiant star, captivating onlookers from its location, generally 6,425 light-years from Earth. Its great distance adds to its status as one of the most completely studied and enthralling heavenly objects visible in the night sky. The data we have about creepy-crawly juice's distance comes from various sources, including the Hipparcos astrometric satellite. This best-in-class contraption has provided fundamental bits of insight into the huge ES. However, isolating heavenly bodies changing data sources sometimes presents disparities. While the Hipparcos satellite shows Betelgeuse to be around 430 light-years away, other estimates suggest a distance closer to 6,425 light-years. These distinctions highlight the intricacy and difficulties of precisely estimating heavenly distances, featuring the continuous refinement and progression in galactic strategies. Getting it, the immensity of our universe involves wrestling with the colossal distances between divine items. Scarab Juju, with its enthralling inconstancy and gigantic size, offers a compelling case study for cosmologists and astrophysicists. Its unique ascribes and detectable behavior contribute significantly to our comprehension of heavenly advancement and the more extensive universe. The variances in Betelgeuse's splendor over the reference period have prompted further requests and observations. The interesting nature of this red supergiant presents an incredible opportunity to comprehend the life patterns of such monstrous stars and the complexities of their behavior. Astrophysicists and cosmologists have used various instruments and strategies to monitor Betelgeuse, attempting to disentangle the fundamental reasons for its changeability and any potential implications for its future evolution. This particular time of change has sparked increased interest in the star, prompting extensive research and conversations within the scientific community. While there have been speculations about a potential cosmic explosion event, the ongoing dimming and subsequent brightening of Betelgeuse raise more inquiries than answers. It's critical to exercise caution in making judgments, as normal variances in a star's brightness are part of its characteristic nature and may not necessarily indicate an upcoming dramatic event like a cosmic explosion. The many-sided dance of understanding heavenly bodies involves taking into account various boundaries, including size, temperature, distance, and their innate attributes. Betelgeuse remains a significant divine item, offering valuable insights into the behavior and life cycle of gigantic stars. Persistent observations and innovative advancements continue to shed light on the confounding nature of Scarab Juju, adding to a broader understanding of the universe. Scarab Squeeze, also known as Alpha Orionis, stands out as one of the most striking and enthralling stars in the Orion heavenly body. Its amazing changeability in apparent size, going from 0 to 6 magnitudes, makes it a variable star. Despite the fact that Riel holds the designation of Alpha Orionis, creepy-crawly Juice's impulse sometimes causes it to seem more brilliant than it actually is. Generally, the designations Alpha Orionis and Beta Orionis were assigned to Betelgeuse and Riel, respectively, in Jan Bayer's Uranometria published in 1603. This arrangement helped cosmologists and stargazers recognize and differentiate between stars in the Orion heavenly body. Dissimilar to many other stars, Betelgeuse exists as a lone star, not part of a larger heavenly group. It lives in a region without star-forming activity. Its classification as a runaway star further distinguishes it, reflecting its trajectory and distance traveled through space. This titanic divine item boasts a radius generally multiple times bigger than the Sun and a mass multiple times more significant than our solar system's star, with a magnificent radiance equivalent to 126,000 suns. Scarab Juice's splendor remains significant even at a distance of 548 light-years from Earth. Notwithstanding its extensive distance, Betelgeuse presents an interesting contrast to our Sun. The star's surface temperature, around 3,600 Kelvin, is strikingly cooler than the Sun's 5,778 Kelvin. Regardless of its colossal size, this temperature discrepancy contributes to its particular red supergiant appearance and serves as a significant variable influencing its brightness and observable qualities. In regards to age, Insect Juju, at around 10 million years old, is relatively young compared to our Sun, which boasts an age of about 4.6 billion years. Notwithstanding its youth in cosmic terms, Betelgeuse has already undergone heavenly evolution, reaching a stage where it displays the characteristics of a maturing red supergiant. Given its massive size and its stage in the life cycle of a massive star, hypotheses about Betelgeuse possibly taking its life in a cosmic explosion event have arisen. Such an occasion, if it were to happen within a couple hundred light-years from Earth, would undoubtedly have significant repercussions for our planet. The plausibility of scarab juice going supernova has garnered attention due to the potential impact such an event could have on Earth. Anyway, scientists stress the need for caution in anticipating such massive phenomena. While insect juice's vehicle characteristics and behavior make it an interesting subject for study, the specifics of a potential cosmic explosion and its ramifications for Earth remain uncertain. Grasping the life cycle and behaviors of stars like Betelgeuse helps space experts comprehend the universe's cycles, and observations of this red supergiant continue to enhance our insight into heavenly advancement and the stupendous cosmic events shaping our universe. Regardless of all the hype about creepy-crawly juice-going cosmic explosion, it hasn't occurred yet. Rather, the star has been dimming and brightening in a pattern suggesting it is simply going through a phase. It is possible scarab juice may ultimately detonate. However, it doesn't seem like it will happen anytime soon. Scarab juice's location in the Orion group of stars, marking the right shoulder of the Hunter, has made it a conspicuous and easily recognizable feature in the night sky. Its unmistakable red tone further enhances its visibility. This star is strategically placed for observation in the night sky, especially during the early months of each year, making it a popular focus for space experts and skywatchers alike. To disentangle the mystery of Betelgeuse's behavior, analysts have extensively analyzed data from various sources, including NASA's Hubble Space Telescope and different observatories. These perceptions have provided critical insights into the star's later activities. The findings suggest that Betelgeuse went through a massive surface mass ejection in 2009, resulting in the loss of a significant portion of its apparent surface. This conduct is noteworthy and exceptional in the context of heavenly perception. Never before has such a peculiarity been seen in a star of scarab juice's size and visibility. Certainly, Betelgeuse, also known as Bug Juju, is a fascinating red supergiant star located in the constellation Orion. Its apparent brightness can vary significantly, making it one of the most easily recognizable stars in the night sky. While often confused with characters from popular culture, its astronomical significance is profound. At around 700 light-years from Earth, Betelgeuse is classified as the closest star likely to end its life in a dramatic supernova explosion. Renowned astrophysicist Neil deGrasse Tyson has noted its immense size and distinctive red-orange hue, which contributes to its visibility. The star's size is staggering. It's about 1,000 times larger than our Sun, and can shine with a brightness equivalent to 126,000 suns at its peak. Betelgeuse has undergone significant changes in brightness over the years, with variations that can be observed even by amateur astronomers. It's a variable star, and its brightness can fluctuate from 0 to 6 magnitudes. This variability has sparked interest in understanding its life cycle and behavior, especially since it is currently in a stage where it exhibits the characteristics of an aging star. The star has been extensively studied using advanced telescopes like the James Webb Space Telescope and the Hubble Space Telescope. These observations have provided insights into its behavior, revealing that it underwent a massive surface mass ejection in 2009, losing a considerable portion of its visible surface. Despite its potential to explode in a supernova, scientists caution against jumping to conclusions. The cyclical nature of stellar behavior means that normal variations in brightness don't necessarily indicate an impending explosion. Instead, Betelgeuse may simply be going through a typical phase of its life cycle. Interestingly, Betelgeuse has various names across cultures, reflecting its historical significance in astronomy. The name is derived from the Arabic Ibt al-Jawza, meaning the giant's shoulder. This naming history highlights the way different cultures have observed and documented celestial bodies over centuries. Despite being relatively young at around 10 million years old, compared to our Sun's 4.6 billion years, Betelgeuse has already traveled through considerable stages of stellar evolution. It resides in a region of space devoid of star formation activity, classified as a runaway star due to its trajectory. Its temperature, about 3,600 Kelvin, is cooler than the Sun's 5,778 Kelvin, contributing to its distinctive red appearance. This temperature difference is crucial in understanding its stellar evolution, particularly as it expands and consumes its nuclear fuel. Astronomers continue to monitor Betelgeuse closely to understand better its life cycle and the implications of its eventual demise. While its variability in size present intriguing questions, they also remind us of the complexities of celestial phenomena and the need for caution when interpreting stellar behavior. The ongoing study of Betelgeuse not only enhances our knowledge of this particular star, but also contributes to a broader understanding of the life cycles of massive stars throughout the universe.